Hi there, Geometry. Welcome to section 3 of the exam review. And in this one, we'll be talking about circles. So let's take a look. It looks like we have 6 questions over circles, so this will span 2 different pages. So let's just go ahead and jump right into this first one. It says find the perimeter of triangle ABC. One of the things that we should know is the distance of 2 tangents. So these are all tangent lines. AB is a tangent line to the circle because it touches the circle on just one point. The segment BC is a tangent line because it touches the circle on just one point. And AC is also a tangent line. So I have 3 different tangent lines to the same circle. And these tangents intersect one another at points A, B, and C. There is a theorem that says that the distance of that intersection point to the points of tangency are always the same. So if the distance from A to D is 10, then the distance from A to F is also 10. If the distance from D to B is 15, then the distance from B to E is also 15. And if the distance from C to F is 8, then C to E is also 8. That is the theorem that this question is really trying to get us to. And then it wants us to find the perimeter. So the next thing we need to know is the perimeter, I'll call it P, is equal to the sum around the outside. So if I'll start at F, A to D, that's 10 and 10, which is 20. And then from D to B is 15 and another 15, so that's 30 more. And then I have 8 and 8, which is another 16. If I were to add all this up, 20 and 30 is 50, plus 16 is 66 centimeters. So that is 66 centimeters for number 1. Number 2, find the variables. This section was in the circles unit, and we have a couple of different things going on. If the inscribed angle. So if we have an angle whose vertex is on the circle, then its measure is half of its intercepted arc. So A is going to equal half of this arc right here. I need to find that arc. And in order to find that arc, I need to know that around a circle is 360 degrees. So 360 degrees, I have a 90 and a 96. So if I do 360 minus 90 minus 96, it's going to be 174. So this arc is 174 degrees. So angle A is half of 174 degrees. So A is 87 degrees. Okay, for the second part to this one, the second circle, we have a property that says that if an angle is inside, so it's created by 2 chords intersecting inside a circle, that its measure is half of the sum. So if I want to find this angle or this angle, it's going to be the same. So I'm just going to mark one on this angle right here. Let's go ahead and call this D. Right? Angle D. Angle D is going to equal half of the sum of the 2 arcs that it makes. So it makes that arc in the front and that arc in the back. So if I take 94 plus 56, add them together and divide it by 2, I find out that that measure is 94 and 56. That would be 150, and half of 150 is 75. So this measure in here is 75 degrees. Well, that'll help me find C really easy, because C and 75 make up a straight line. So I can do 180 minus 75 is 105. Angle A, if I look at where angle A sits on the circle, so it's half of its other opposite arc. So that opposite arc is right there, which is 56. So A is half of 56, which is 28. degrees. And B, if I look at B, it makes this arc over here. So B is half of that arc, which is half of 94, which is 47 degrees. So I would find A to be 28, B to be 47, and C to be 105. Another way to find C, if you didn't like doing what we did to start with, I can look at the vertical angles and say that that is also C. And then the triangle that is made up of angles A, B, and C, I could add those up and set it equal to 180 as well. So two different options to do the same problem. All right, to do the third circle over here on the right, instead of finding x, I'm actually going to find, first of all, one of them that's next to x. I'll call it y. I'm going to find that one using this property of adding them up. So to find y is going to equal these two arcs added up. So 20 plus 28. I'll add them up and divide by 2. When I add 20 and 28, that's 48, and half of 48 is 24. So y is 24 degrees. X and y are a linear pair. So x plus y, which we said is 24, has to equal 180. So that means x has to be 180 minus 24, which is 156 degrees. So knowing a lot about the linear pair theorem and knowing how to find the measures of angles when you have arcs is what this question's really trying to get to. All right, as I scroll down, these next couple of problems have to deal with distances. There were a couple of theorems that we learned about, and if two chords intersect inside of a circle, it is the two pieces multiplied together. So this little piece here, which is 2, times the its next piece, which is 9. So I can multiply the two pieces together of one chord, and it has to equal the two pieces of the other chord. So that would be x and 6. Well, 2 times 9 is 18, and x times 6 is 6x. Divide both sides by 6, and x is equal to 3. When the intersection happens outside of a circle, this one's a little different. This is the outside piece times the whole piece. So I'm going to look first at this. It's actually a tangent line. The outside, the length of the piece that's outside the circle, and I'm thinking this. I'm thinking outside piece times the whole piece. This is what I think, outside piece times whole piece. So this piece here is outside of the circle is x long. The whole piece is also x long. So it's x squared. Okay, when I look at the other piece here, this piece out here, the outside piece is 4 units long. The whole piece is that 4 that's outside and the 5 that's inside. So that whole piece is 9. All right, x times x is x squared. 4 times 9 is 36. Solve by square rooting both sides, and x is equal to 6. So x would have to be 6 units long. All right, moving along. Question 3, determine whether a tangent line is shown in the diagram. Okay, if this line is actually tangent, then this angle here must be 90 degrees. That has to be a right angle. So how can I test to see whether that is a right angle? I will use Pythagorean's theorem to test it. I will check and see if a squared plus b squared equals c squared. If it does, then this is a right triangle and that line is tangent. If it does not, then that line is not a tangent line, and that is not 90 degrees. So how do I check that? Well, let's take the legs. The two legs would be 4.5 and 10. And I'm going to check and see if this thing equals the hypotenuse squared. Well, you can grab a calculator and do 4.5 squared, and you'll get 20.25. You can do 10 squared and get 100. And 12 squared and get 144. And when I add 120.25, I get 120.25, which does not equal 144. And since they do not equal one another, then that angle is not 90 degrees. So determine whether the tangent line is shown in the diagram. The answer is no. It is not tangent. And the reason is because the Pythagorean theorem did not suffice. All right, question number 4. So question number 4 is kind of tricky, I guess. It says the circles are congruent. Now, if the circles are congruent, that means their radius, all the radii are congruent. So that means I'm going to mark them. AE, make this pen a little thinner here. It's a small picture. So AE, that's a radius. And EB and EC and ED, those are all the same. Those are all radii. And UQ and US and UR and UT, those are all radius. So they're all congruent. All right. Let's take a look at some angles that are congruent. So I'm going to change colors here just so I can start seeing the angles. Let's go with a green color. Angles that are congruent. Because arc AB is congruent to arc QR, then this angle and this angle are the same. There's a theorem that says that the arcs, if arcs are congruent, then their inscribed angles, those central angles, are the same. All right. In the left circle over here, you have angle AEB and CED are vertical angles, so those are congruent. As you look at the right triangle, it looks like angle SUT could be the same as angle QUR, but we don't know. We do not know that for sure. There is no way for us to definitively say that, I guess. Yeah, so I just don't know. So really, what things do I know for sure? I know this. That triangle, I'll look in the left circle, triangle AEB is congruent to triangle DEC. I know that triangle AEB is congruent to triangle in the second QUR, by side angle side. And then the transitive property, if the same triangle is congruent to two different triangles, then they would be congruent to one another. So triangle DEC would be congruent to triangle QUR, QUR, by the transitive property or by side angle side. What I cannot do, I cannot include triangle SUT into that mix in any way, just because I don't know for a fact what that measurement of the angle is in the top. It looks like it should be, but we do not know that for sure. All right, question number 5 says find the equation of the circle whose diameter endpoints are -3, 5, and 6, -9. So in order to find this, we have to find two things. The equation of a circle. I need to find the center, and I need to find the radius. If you remember, x minus h squared plus y minus k squared equals the radius squared. So to find the center, I just find the midpoint of the two endpoints. So this is going to be a midpoint here. So the midpoint is going to be add my x's and divide by 2. So -3 plus 6 divided by 2. And add my y's, 5 plus -9 divided by 2. So this is Negative 3 plus 6 is 3 over 2. And 5 minus 9 is negative 4. Divided by 2 is negative 2. All right. So that's my midpoint. So that's the center. And the radius is going to be half of the distance of the diameter, or the distance from the center to either endpoint. So I'm just actually going to calculate this distance. Square root of, if you remember the distance formula, it's x2 minus x1 quantity squared. So negative 3 minus 6 is negative 9 squared plus y minus the y. 5 minus negative 9 is 14 squared. So that is 81. And 14 squared is 196. And if I add 2 or 180, square root of 81, 81 and 96 is 277. Okay, so the whole distance from endpoint to endpoint, this is the diameter. So if I need the radius of this thing is going to be half of that. So half is going to be radical 277 over 2. All right. Oh, that's pretty ugly. So let's take a look at this. If I want to find the equation of the circle, I do x minus h, which is the x value of the center, which is 3 over 2, squared, plus y minus negative 2. Minus a negative is like adding 2, squared. And the radius squared. If I do the square of radical 277, I get 277. And I square the 2 to get 4. So I know it's ugly. It does not look good. I'm really hoping that on the exam you don't have one that's that ugly. But remember this, the exam does have multiple choice. So you would be able to start limiting down based on things that you already know, preferably about signs and those kind of things. Number 6 is a little bit more like it. This is a little bit easier. It says find the equation of this circle. Same thing. I'm going to find the center. So the center, it looks like it's over 3 and down 4. So it's 3, negative 4. And the radius is the distance from the center to the edge, which is 2. And now we'll do the same thing. X minus the x value, which is 3, squared, plus y minus negative 4, so plus 4. And that equals the radius squared. 2 squared is 4. And that concludes circles.